So for today's video, what we're going to do is take a look at the Tools of Geometry, Tools of Coordinate Geometry packet, and we're going to look at the first lesson. So if you flip through, you have your outline and your vocabulary page, and then the next page in your packet is on slope and parallelism, and this is the page that we're going to look at together. So at the beginning of the lesson, it talks about how geometry is the study of space, both two-dimensional and three-dimensional. And so far this year we've looked a lot at plane geometry using transformations, and we've also looked at Euclidean reasoning when we did our proofs. So for this unit, what we're going to do is we're going to look at coordinate geometry to explore space. And we're going to start by just reviewing slope, and this is definitely something that you saw back in algebra. So what we have in the first exercise are two line segments, A, B, and C, D, and they're shown below. We're going to determine the slope of both of the lines graphically. And then just a little reminder that the slope is the ratio of the rise of the line to the run of the line as we move from right to left along the x-axis. So first thing we want to do is find the slope of AB. So I have to find the rise of that segment that goes from A to B, or the change in the y-axis. So the y-axis is the axis that goes up and down. So what I'm going to do is I'm going to start at point A, and I have to try to get to point B, which is over here. And so my change in y is how far I would travel up to go from A to B. So point B is over here, and point A is over here, and so what I have to do is figure out how many boxes or how many units I'm going to have to travel up to get to point B. And so it looks like I'm going to have to travel up 1, 2, 3, 4, 5 units. So the change in y, the change in my y values from A to B, is 5 units. And then my run is how far I travel along the x-axis from left to right. And so my x-axis is this line here. And so what I want to do is figure out how far I would need to travel to go from A to B in the horizontal distance or along the x-axis. And so it looks like I would have to travel 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to go from A to B along the x-axis. So my change in x is going to be 10 units. So then the slope of this line is rise over run. Our change in y is 5, and our change in x is 10. And we can simplify that. We can take a 5 out of both 5 and 10. And when we simplify that, we end up getting 1/2. All right, so go ahead and see if you can come up with a slope for CD. Okay, so it looks like for the slope of CD, we should have a negative slope because our line is pointing down. So to go from C to D, I had to go down 12 spaces and then over 8. And so my rise was negative 12, my run was positive 8, and then I wrote it as my rise over my run, and I simplified it and ended up getting negative 3 over 2. And one way that you can check is you should be able to go from any point on the line, you should be able to go down 3 units over 2, and you should be able to hit the line again. And you should be able to do that from any point on the line. So I should be able to keep going and keep going down 3 over 2, and I should hit a bunch of lines on that segment. Last year in Algebra 1, you also looked at how to find slope and average rate of change. And a lot of times you didn't have a graph to go along with that. So you looked at a formula for finding slope, and that's what we're going to look at next. If you don't have a graph, or you don't have access to graph paper, then what you want to do is use your slope formula. And again, slope formula is rise over run, change in y over change in x. And basically what you want to do is subtract your y values to get your change in y, and subtract your x values to get your change in x. And it really doesn't matter if you do y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2, as long as you're consistent. So let's do one of these together. So for the first one, we have point A, and that's my first x value and my first y value. And then point B is my second x value and my second y value. So to find the slope, I'm going to find my change in y and my change in x. So my change in y is what I get when I subtract my y values. So I'm going to subtract 10 minus 4. And if I started with my second y value on the top, if I did 10 minus 4, on the bottom I have to go in the same order. So I would have to go 8 minus negative 2 on the bottom. but 8 minus a negative 2 is 8 plus 2. And so when I clean that up, I get 10 minus 4, which is 6, and 8 plus 2 is 10. And then simplify that, I can take a 2 out of both 6 and the 10, and that leaves me with 3/5. And so the slope of that line, or slope of a line that goes through those 2 points, would be 3/5. All right, so go ahead and see if you can find the slope for the other 2. Okay, so hopefully you were able to find the slope of those 2, or of the line that went through those 2 pairs of points on the front of the page. It's not something I'm going to go over, but I do expect that you do them. It's review, totally review from algebra, so hopefully that dusted off some of the cobwebs, and we can move on. So with the back of the page, we looked a lot at parallel lines earlier this year. We looked at parallel lines cut by a transversal, and then we used the parallel lines in our proofs. And as we know, 2 parallel lines that do not are lines that do not intersect. And what we're going to look at is the slope of those 2 lines. So what we have in the picture here are lines, and what we want to do is name 2 pairs of parallel lines. So to me, it looks like line R and line N are parallel. So I'm going to say that R is parallel to N. And it says that there's 2 pairs, so it also looks like line S is parallel to line M. And now the next thing it wants us to do is determine the slope of each of the lines that make up the pairs. So we're going to find the slope of line R, we're going to find the slope of line N, and then we're going to find the slope of line S and the slope of line M. So for line R, I'm just going to pick 2 points that are on that line. And the rise looks like it's going to be 1, 2, 3, 4, 5 units down and 2 units over. So for R, I have to travel down 5 units and over 2. For the slope of line N, if I look at one point and try to go to the other, I go down 5 units and over 2. And then if I look at the slope of line S, if I pick 2 points, it looks like I'm traveling up 2 and over 3. And if I look at the slope of line M, to go from one point to the other, I'm going up 2 and over 3. So it appears that parallel lines are going to have the same slope. We said that line R and line N were parallel, and they had the same slope. And line S and line M were parallel, and they also have the same slope. So from this exercise, what seems to be true about the 2 lines that are parallel, they will have the same slope. All right, so basically 2 non-vertical lines will be parallel if and only if they have slopes that are equal. So now what we want to do is we want to try to determine if AB is parallel to CD and give some kind of evidence to support our answer. So what we're going to do here, what I'm going to do is I'm going to find the slope of AB, and then I'm going to find the slope of CD, and I'm going to see if those 2 slopes are equal. If they're equal, then the lines are parallel. So here's what we have. For A and B, I have those 2 points right there. And I don't have a graph, so I'm just going to subtract 7 minus 1 for my y values, and 6 minus negative 2, or 6 plus 2, for my x values. And so 7 minus 1 is 6, 6 plus 2 is 8, and so it looks like the slope of that line is 6 over 8. And that will simplify to 3 over 4. And now I'm going to take a look at CD. So CD, I'll subtract 6 minus negative 3, so that's 6 plus 3, and then 8 minus negative 4. And then we'll just go ahead and combine those. 6 plus 3 would be 9, and 8 plus 4 would be 12. And then we can take a 3 out of both of those, so we end up with 3 and 4. And so it looks like they have the same slope, which means AB is parallel to CD. All right, so see if you can try the next one. See if AC is parallel to BD. So do exactly the same thing. Check the slope from A to C check the slope from B to D, and determine if they have the same slope or not. And then the last one is a bit of a challenge problem, I think. With this one, it says that we have some point E that exists, such that its x-coordinate is 12. So we have some point E, and its x-coordinate is 12. And we know that ED, so from E to D, and D is the point 86, we know that that's parallel to AC. So then what would the y-coordinate of point E have to be? And then show how you arrived at your answer. So if you think graph paper would help, that's fine. If you think that you can work it through with the equation, that's fine. But see if you can come up with a value for the y value of that coordinate.